In this video, we're going to use calculus to determine the length of curves. So if you remember when you worked with right triangles, we had Pythagorean theorem. And so Pythagorean theorem just says that the length of the two sides of a right triangle when squared, their sum, will equal the square of the length of the hypotenuse. So if here's my right triangle and I have side A, side B, hypotenuse C, Pythagorean theorem is a squared plus b squared equals c squared. Well, when I'm looking at a big curve and it's super curvy, if I blow it up and I look at a teeny tiny little section of it, I can force it to have a right triangle. And in this case, this would be my change in x, my change in y, and so the change in length would be the square root of the derivative of x squared plus derivative of y squared. So we can extend this and use this to figure out the length of a curve by finding all of these little itty bitty pieces as we look around our curve and then summing them all together, so using an integral. So as we want to approximate this curve, we're going to measure the shorter and shorter line using our Pythagorean theorem. So we solved for the change in length is given by the square root of dx squared plus dy squared. So to find my actual length, I need to integrate this. And so when I integrate the derivative of L, I'm going to get just L, that change in L. So that's going to be the integral of, and so now we got to do a little bit of math to clean this up. So we got common denominators, dx squared over dx squared. So dx squared over dx squared is just 1. Then we have dy squared over dx squared, which I can write as dy dx squared. And remember from our notation that dy dx is really just f prime of x. So essentially we're going to take the derivative of the curve we want to find the length of, square it, add 1, take the square root, and then take the integral of that. So to clean that up, we can look at it this way. So any arc length L is given by the integral from a to b for the end bounds of the length we're trying to find, radical 1 plus derivative of our function squared dx. Note that the derivative absolutely has to be continuous on our interval in order for this to work. So in this one, we want to find the arc length of y equals 3x plus 1 on the interval 1 to 4. Well, this is a straight line, so this is a good example to show us why using Pythagorean theorem and using that formula will work. So if I sketch this, 1, 2, 3, 4, when x is 1, y is going to be 4. When x is 4, y is going to be 13. This is not to scale, but it's a straight line, so I can easily use Pythagorean theorem, and I know this side is 3, this side is 9. So using Pythagorean theorem, I have 3 squared plus 9 squared equals c squared. So 9 plus 81 equals c squared, so 90 equals c squared, and I have 3 squared of 10 equals c. So now we want to verify that this arc length formula works. So the first thing I need to do is find my derivative. So the derivative of 3x plus 1 is just 3. The second thing I need to do is take that derivative and square it. So 3 squared is 9. So this is what I'm going to use in my formula. So arc length is equal to the integral from my bounds 1 to 4, the square root of 1 plus that derivative squared, so I'm plugging in my 9, dx. So this is the integral from 1 to 4, the square root of 10 dx. So this is equal to the square root of 10 times x evaluated from 1 to 4. So I have the 4 square root of 10 minus square root of 10 gives me 3 square root 10. Right? Now the tricky part on these sometimes is cleaning up and finding that derivative and squaring it and evaluating the integral. But if it's not a straight line, we have to use the formula. So here we want to find the arc length of the curve y equals 1/6 x to the third plus 1 over 2x on the interval 1 to 2. So here's our sketch. Here's where we're looking. That's the little region we want. So the first thing we need to figure out is what is y prime. So y prime is going to be 1/2 x squared minus 1 over 2x squared. Okay. The second part, before I even go to my formula, is I need to figure out what that is when I square it. So I have to square it. So y prime squared is going to be 1/4 x to the fourth. I'm going to have 1/2 x squared times negative 1/2 x squared is going to be minus 1/4. Then I'm going to have that again and another minus 1/4 and then plus 1 over 4x to the fourth. So when I clean this up, I have 1/4 x to the fourth minus 1/2 plus 1 over 4x to the fourth. All right, so that's my y prime. So now I'm going to switch colors so we can see it a little bit better. We're finding our arc length. So our arc length is equal to the integral from 1 to 2, the square root of 1 plus that whole thing. So 1 plus 1/4 x squared minus 1/2 plus 1 over 4x to the fourth dx. So when I clean up inside, I have the integral from 1 to 2. The 1 and the negative 1/2, this becomes 1/4 x squared plus 1/2 plus 1 over 4x to the fourth dx. And now if I notice, this is almost the same as what I had before, except this is a positive. This is a perfect square trinomial. This factors very nicely. Okay, so giving us more room, we had the integral from 1 to 2, the square root of 1/4 x to the fourth plus 1/2 plus 1 over 4x to the fourth dx. And I said this is going to be a perfect square trinomial, so this factors nicely. So this factors to the integral from 1 to 2. This would be the square root of 1/2 x squared plus 1 over 2x squared dx. So I'm taking the integral from 1 to 2 of 1/2 x squared plus 1 over 2x squared dx. And so now I'm just evaluating my integral. So I'm going to have 1/6 x to the third plus the 1/2, and then the integral of 1 over x to the second is going to be times negative 1 x to the negative first, and I'm evaluating that from 1 to 2. So I'm going to clean it up a little as I go here. So 2 cubed is 8, so I'm going to have 8 over 6. This is 1/2 times negative 1 is going to be minus. 2 to the negative 1 is 2, so that's minus 1/4. Minus, and now I have to plug in my 1. 1 cubed is 1, so that's going to be 1/6. 1 to the negative first is 1 over 1, so that's going to be minus 1/2. And then I just need to clean this up with a little bit of algebra, and I should get 17 over 12. So when you're working with these, the algebra can get pretty complex, so make sure you remember to set up your problem first, find your y, find your derivative, sometimes do the whole thing, 1 plus the derivative, and factor that first. So you got to remember to use your algebra to manipulate those expressions into something that you can actually integrate.